Hi everyone. Today we are going to talk about solving special systems of linear equations. So these are systems that have kind of unique answers. So when you're solving a system of linear equations, there are three possibilities for the type of answer you'll get. So if you have two lines that intersect, you will end up with one solution, and that solution is that point of intersection. So I think most systems of equations will cross somewhere and they will have one solution. However, it is possible that you have two equations that are actually the equations of parallel lines. And since parallel lines never cross, there is no solution. So that is the second possibility when you're solving a system of linear equations. The third possibility is that you have two equations that actually make the same exact line. So you can kind of imagine there's one line that's on top of another, and since they are crossing or they're intersecting at every single point, we say that there are infinitely many solutions. So these are the two we're going to focus on today. These are the two kind of unique cases when the lines are parallel and we have no solution, and when the lines are the same, so we have infinitely many solutions or infinite solutions. So let's first look at a system that has no solution. We're going to solve it graphically and algebraically to see what it looks like in both ways. So if I graph these two equations, remember I'm looking for the point of intersection. For the first equation, I see that my y-intercept is at 0, 1. And I see that my slope is 3 over 1, telling me to go up 3, right 1, or backwards, down 3, left 1. So I get a line that looks like this. And then if I graph the second equation, I see that I have a y-intercept of -5, 0, -5, and I have that same slope of 3 over 1. So I can follow my slope and connect my dots. So you'll see that since these two lines have the same slope, they're increasing at the same rate, and therefore they're never going to cross. So if you ever see a case like this and you notice right off the bat that they have the same slope, you don't need to actually graph it. You can just say parallel lines, and then your final answer is no solution. So you should explain why there's no solution, but you don't have to go through the process of graphing it if you know that your two lines are never going to cross. Now let's say we don't want to graph. Let's say we do this algebraically. So if you remember the substitution method, we can use that to solve here. So this 3x plus 1 is equal to y, and 3x minus 5 is also equal to y. So since they're both equal to y, they're both equal to each other. So we're essentially substituting one into the other. So we can say 3x plus 1 equals 3x minus 5. Another way of thinking about this is we substituted this y with what y is equal to. So if I start solving here, I see that I have variables on both sides, so I'm going to move it by subtracting 3x from both sides. And you'll see that my x terms disappear. So remember, when you do this, you want to see what you have left over. And if the equation that you have left over doesn't make any sense, like 1 is equal to -5, which it is not, if you have an equation that doesn't make any sense, we would say no solution. So whether you solve this graphically and you can physically see that there is no solution, or whether you solve it algebraically using substitution and then you get a nonsense equation, either way you will come to the conclusion that there is no solution. All right, so now let's see what it looks like when there is an equation that has infinitely many solutions. So let's look at this first one and let's try to solve it graphically. So this is something that we can graph. I see that the y-intercept is -3, and I see that my slope is 2 over 1. So I can follow my slope, and this is the graph of this first equation. Now for me to solve that second equation, I am going to need to rewrite it in slope-intercept form. So I'm going to start by adding 4x to both sides, and I get 2y equals 4x minus 6, and then I can divide both sides by 2. So we get y equals 2x minus 3. So you'll notice that I actually end up with the exact same equation as my first equation. We have y equals 2x minus 3 here and y equals 2x minus 3 here. So if I went to graph this again, it would literally be right on top of my first line. So you can see that our lines are intersecting at an infinite number of points. So if you ever see that two equations actually make the same line, we say infinite solutions. So remember, these two equations, at first they don't look the same, but if you rewrite it, you see that they actually are the same. Now let's say we decide to solve this algebraically instead of graphically. Let's do substitution method here. I know that y is equal to 2x minus 3, so I can substitute 2x minus 3 for y right here. So I'm going to substitute it into the second equation. So I'm going to take out the y, and I'm going to replace it with 2x minus 3, because we know that y is equal to 2x minus 3. So I substituted that right here. Now I can solve. So first I'm going to distribute. We have negative 4x plus 4x minus 6 equals negative 6. So when I go to combine like terms, what you'll actually see is that my x terms disappear again. Negative 4x plus 4x is 0 x's, so I'm not going to write any. That leaves me with negative 6 equals negative 6. So when your variable disappears, remember, you look at the statement you have left. And if it makes sense, like in this case, it does. Negative 6 is equal to negative 6. That means that we have infinite solutions. So in contrast, our last problem, we had something that didn't make sense, which means you get no solutions. But if you have an equation that is true, like negative 6 is equal to negative 6, that means infinite solutions. So whether you solve this algebraically or graphically, you will come to the same conclusion. So whatever method you prefer is what you should stick with. Okay, go ahead and pause the video and see if you can try these 3 problems. You can try to solve them either graphically or algebraically, whatever you think is easiest. Okay, so let's start with, let's look at the first one. So you can see these are both in slope-intercept form, and you can see that we actually have the same slope. So since we have the same slope, we know that these lines are parallel, and parallel lines never cross. So we know that our answer is no solution. We don't even have to graph it because we were able to justify our answer here. Now for the second one, this first equation is in slope-intercept form, so I rewrote the second equation in slope-intercept form, so I subtracted 5x from both sides. So this is the system that I had once I rewrote it. So I have y equals negative 5x and y equals negative 5x minus 2. So we have another case where we have two lines with the same slope. So these two lines are parallel, they will never cross, and therefore we have no solution again. Now this last example, number 6, I wanted to solve this algebraically, so I decided to use the elimination method. So remember, our goal with the elimination method is to create opposite coefficients. So I noticed this is a negative 12, and I knew that I could turn this into a positive 12 by multiplying my top equation by 6. So when I do this, I end up with 12x minus 24y equals 60. So if you go to add vertically following the elimination method, well, this is 0, and so is this. So we end up with the statement 0 equals 0. Since this is a true statement, that means we have infinite solutions. So remember, when your variables disappear, and if you're left with a statement that is true, it means infinite solutions. Okay, that is all for today's lesson. Thank you so much for watching.